Understanding welding symbols and standards, AWS versus ISO. When reading piping isometric and construction drawings, one of the most essential skills every engineer and fabricator needs to know is how to read welding symbols correctly. Depending on where a project is being designed, there are two common welding symbol systems in use: the American Welding Society, AWS, which was the standard baseline until 1992, and ISO 25453, which has mostly been adopted across Europe and its affiliate countries. In this video, we're going to cover the most important AWS and ISO 25453 symbols, along with clear examples showing what they actually mean on a real drawing. No matter which standard you're using, every basic welding symbol consists of three core components. 1. The arrow line points directly to the joint where the weld needs to be made. 2. The reference line, the horizontal line where all symbols, dimensions, and instructions are placed. 3. The tail, the optional end piece used to show specific welding processes or WPS numbers. Let's start by looking at how to properly read welding symbols under the AWS A2.4 standard. The AWS A2.4 standard defines a system of welding symbols used on technical drawings to specify joint types, weld types, and dimensions. Under AWS A2.4, a symbol placed below the reference line indicates the arrow side, the actual side of the joint the arrow is pointing to. A symbol placed above the reference line indicates the other side, the opposite side of the joint. Let's check out a few of the welding symbols used in the fabrication workshop that follow the AWS A2.4 American Welding Standard. Welders use the Fillet weld, pronounced fillet, to make lap joints, corner joints, and T-joints. Let's learn step by step the most commonly used welding symbols in manufacturing and their corresponding as-built welded appearances. Let's first look at the Fillet weld symbols, their notation, and their as-built equivalent. On an engineering drawing, a fillet weld is represented by a small right triangle symbol placed on the reference line. If the triangle is positioned on the bottom side of the reference line, it indicates that the fillet weld must be applied directly on the arrow side, the side of the joint to which the leader line points. If the triangle is positioned on the top side of the reference line, it means the fillet weld must be applied on the other side, the opposite side of the joint away from the arrow. If triangles appear on both the top and bottom sides of the reference line simultaneously, it indicates that the fillet weld must be applied on both sides of the joint. The completed weld forms an approximate right-angled triangle shape connecting the two intersecting plates or components. In lap joints, two overlapping plates or components are joined together by applying a fillet weld along the edge of one member against the surface of the other. This type of joint is widely used in structural and piping fabrication due to its excellent load-bearing capacity and relatively easy fit-up preparation. In corner joints, the edges of two members meet at an angle, typically forming an L shape, and a fillet weld is deposited along the inside or outside corner to secure them firmly together, providing strong structural integrity at the edges. If you look at most blueprints or weld symbols, you'll usually see a number sitting right before the fillet weld symbol. What that number's telling you is the leg size of the weld, basically, the length of one of the sides. It's super important for making sure the weld is the right size and actually holds up to the design specs. If you look at most blueprints, you'll usually see a number sitting right before the fillet weld symbol. What that number's telling you is the leg size of the weld, basically, the length of the sides. For example, if you see an 8 right in front of the symbol, that means the leg size on both sides of that fillet weld needs to be 8 mm. Or, if you see a 12, then each leg size has to be built out to 12 mm. It's super important for making sure the weld actually matches the prints and holds up to the design specs. Sometimes you'll run into what we call intermittent or stitched welds. Instead of running a solid bead all the way down the joint, you weld for a specific length, skip a section, leave a gap, and then weld that exact same length again. You just keep repeating that pattern evenly all the way down the joint until you hit the end. The cool thing is, all these dimensions are spelled right out on the weld symbol. Just like normal, the leg size of the fillet weld is written right in front of the symbol. But over on the right side of the symbol, you'll see two numbers showing you the length of the weld and the spacing or gap between them. Let's look at an example to break this down in more detail. If you see an 8 on the left side of the symbol, that means the leg size, the length of one side of the fillet weld, is 8 mm. Now, let's learn more about welding symbols specifically through the lens of beveling groove welds. Above the reference line, when a beveling groove weld symbol is placed above the reference line, it instructs the welder to perform the edge preparation and weld on the other side, the side opposite to the arrow side, of the joint. Below the reference line, conversely, placing the beveling groove weld symbol below the reference line specifies that the beveling and welding must be executed on the arrow side of the joint, directly facing the pointer. On both sides of the reference line, if the beveling groove weld symbols appear on both sides of the reference line, it indicates that symmetrical beveling and welding are required on both sides of the joint to ensure complete joint penetration. Let's explore another common type of groove weld symbol, the V-groove weld. Here is how the rules apply to a V-groove weld. Below the reference line, placing the V-groove weld symbol below the reference line instructs the welder to execute the V-shaped preparation and welding on the arrow side of the joint. Above the reference line, when a V-groove weld symbol is placed above the reference line, it directs the welder to perform the V-shaped edge preparation and welding on the other side, opposite to the arrow side, of the joint. On both sides of the reference line, when V-groove weld symbols appear on both sides of the reference line, it means a double V preparation and weld must be performed on both sides of the joint for maximum structural strength. Now, let's check out a few of the welding symbols used in the fabrication workshop that follow ISO 2.4, which is an international standard. If the weld symbol, triangle, is placed on the continuous reference line, solid line, it indicates that the fillet weld must be applied on the arrow side of the joint, the side to which the arrow points. If the weld symbol is placed on the dashed, broken, reference line, it means the fillet weld must be applied on the other side, the opposite side of the joint away from the arrow. Just like in AWS, under ISO 2.4, if the welds are symmetrical on both sides of the plate, the dashed line is dropped. Now, let's learn more about ISO 2.4 welding symbols specifically through the lens of bevel groove welds. When a bevel groove weld symbol is placed on the continuous reference line, it instructs the welder to perform the edge preparation and weld directly on the arrow side of the joint, the side facing the pointer. Conversely, placing the bevel groove weld symbol on the dashed, broken, reference line specifies that the edge preparation and welding must be executed on the other side, the side opposite to the arrow side, of the joint. When looking at engineering drawings, the site weld, meaning a weld that must be performed out in the field during installation rather than in the workshop, is clearly indicated by a small flag symbol located right at the junction where the reference line meets the arrow line. Next, let's look at continuous joints. The weld all-round symbol is represented by a circle located right at the junction of the reference and arrow lines, signaling that the component requires a continuous peripheral weld, usually done in the workshop. The best part is that these standard symbols are fully combinable, allowing you to specify an all-round weld that has to be done on-site. Alright guys, we covered the basics of welding symbols and the differences between AWS and ISO standards. Always remember to check the title block first to see which standard applies. Now, in our upcoming videos, things are going to get really practical. We're going to analyze real pipe spools, break down welding symbols directly on actual shop drawings, and look at how to read piping isometric drawings and structural drawings easily and step by step. If you want to master reading drawings without any confusion, you are definitely in the right place. Drop your questions in the comments below, hit that like button, subscribe to the channel, and share it with your colleagues. Thanks for watching, and see you in the next one.